Good afternoon, grade 11 students. Here's an example of your third and last piece that is outstanding. This was supposed to be your construction practical, which you did not get to do because of the pandemic. However, here's a representation of what you would have done. It is a YouTube video which I'm going to send you the link for, and it is simply basically setting out a concrete slab. All the steps that are required in terms of marking out ground, excavating, setting up your formwork, and setting up your matting, and pouring in the cement, mixing the whole process. Now, you will have to watch this video on your own. This tutorial is just to help you now with the filling out of the plan sheet for construction.
Into the concrete and
So,
surface, and
for those who don't understand, you have to do a plan sheet for the furniture construction project, as well as a plan sheet for your construction project. Now, the plan sheet for the furniture project would involve you filling out a form and doing drawings for the cupboard that you had made in the workshop. This plan sheet now that we're looking at now is a plan sheet for a construction project, which you did not get to do, as I said before, but we're going to do it in an hypothetical sense, meaning that we're going to pretend as if you hadn't done it and run you through the steps that are required. Here's a simple example of what the plan sheet looks like. It's 4 pages, and these 4 pages include page 1, isometric, page 2, orthographic. These are isometric drawing and orthographic drawing, and page 3 would have the list of tools, materials, and processes, and step 4 or page 4 would now be a breakdown of the material sheet in terms of amount, costing, and a more detailed breakdown of the material list. But before we get into filling out the plan sheet, you first need to understand what it is that you would have been making. I refer to another video. You may have been seeing people making slabs such as these.
We're going to extend it out a little bit
and
further.
At some point you may have picked up some of the steps involved, but by watching these 2 videos which I'm going to send to you, you'll have a pretty good understanding of all the main steps that are involved, and from watching the video you'll be able to pick up all the steps that you need to do in order to fill out your plan sheet. But let me break down the information for you in a more simple way, using a 3D version of a concrete slab which was made in AutoCAD for explanation purposes. Alright, so what do we have here? Simple, your brown section here would represent the earth. The yellow box around it would represent the plyboard that you'd use to make your formwork, and the blue section will represent the concrete that you're going to pour inside and let it dry. And once you do that, you can remove the plyboard around it, and that leaves you with a slab of concrete. That is simply how a regular pavement would have been made, or the corridor at your school, whichever. For the explanation purposes, let us remove some of the things that would have been done previous to the making of this video. I'm going to turn off all of these layers to break down the drawing down to its basic form, and then we start from scratch. Alright, so we start out with the ground. Ground would have been there, and you decided that you'd want to make a concrete slab in an area of the ground. Now, this area here that you see in that lighter color would represent the spot that you have selected for the concrete slab to be placed, and so you draw lines. Now, in grade 10 you would have done a practical for site layouts, profile board setup, and that's when you would have used the pegs, profile boards, butter boards, cords, and such to set up a 3-4-5 method in order to identify the foundations of a building or the perimeter of the building, using other methods to check for squareness of the building and such forth. A similar method could be used here, where pegs could be set up using the 3-4-5 method to identify all 4 corners, and 3-4-5 method to make sure that each corner is square, using diagonal method to make sure that the box itself is square. Alright, let us go into it. Step 1, and while I'm explaining while I'm explaining the process, I label or note each step. So if you watch the video and follow carefully, you'll be able to make notes from the video. Alright, so step 1, excavation. Step 1 is excavating. Excavating means removing any soil or gravel or dirt or material from the site. So simply like that, a hole would have been dug, right? Or prior to step 1, you would have had to mark out with your profile board. So we say mark out and then excavation. So after you have excavated the site, then you have a hole here that you're gonna now try to fill with concrete. But before you fill it with concrete, you must prepare the site or prepare the spot of ground for accuracy of the formwork, and you know that cement or mortar in its state of being mortar, in its liquid form or paste form, it won't stand on its own so much. So what you need to set up is a formwork, which is like a box made from plywood or 2x4s or 2x6 or lat boards, whichever board you choose depending on what the situation is, using those boards to make like a box or a barrier that when you pour that liquid cement or concrete, liquid mortar inside of it, it will stay in place until it dries and hardens. So from there, you would have to now put in a level of gravel. The gravel would be something like a foundation that makes it harder for the ground underneath to sink. Let's refer back to the YouTube video for a second. If you were to check with the previous video that we were trying to view, there's a stage in this process, if I can skip towards it, after digging out, that the individual would have set up profile boards, and after checking squareness and such, you would fill that area with gravel. Here we go. So if you notice that specific size stones or gravel would have been placed at the floor or at the base of the formwork to set a level, solid, tough hardcore for the pavement to be set on. Alright, so this layer is called your hardcore, and in our example, our hardcore is about 150 millimeters. That's about 6 inches. So after setting out your profile board, step 1, then excavating the soil, step 2, then step 3 now would be to lay and compact the hardcore layer. Hardcore layer, as we said before, is just gravel. From that step, it is now time to set up a formwork. You can start your formwork by putting in pegs. Once these pegs are inside of the ground, you can now there you go. So now that these pegs are in place, they now create a steady frame for you to put your plyboard on. And so those plyboards now would have been nailed in or screwed in to the pegs. These pegs are about 2x2 pegs or 2x2 boards driven into the ground. If you take one out, just pick one of them, there we go. You'll see that the tip of it naturally would have been sharpened for better penetration into the ground. Alright, but let's put that peg back where it came from. So with all pegs in the ground, and your plyboard can be set around it, and now you have a good enough box. Notice that this plyboard goes, or the formwork goes higher than the ground itself, because what you want is for the slab to be higher than ground level. Alright, and the cement, of course, would now be laid inside of it. But before you start to put your cement in, you need to put some steels inside of it that would make it less likely to crack. let's follow in the steps that goes afterwards. This is an example of what we're talking about. So our mesh here that you see is made from regular steel, rigid rebars, reinforced steel bars that will be placed and tied together with binding wires. So each time it makes a 90-degree corner, a binding wire would have been placed there to tie it together. So let us move back to our 3D example. So here we go. Your rebars, as you can see, will be one piece of steel laid on top of another, and when they meet, binding wire will tie them together. Alright, so good so far. However, from that point now, there's an issue where the rebar needs to be placed in the center of the concrete slab that you're going to pour, meaning that no part of the steel can be going anywhere near the edge. So let us remove some of these layers so that we can see better of what we're talking about. Let's get rid of the ply for now and get rid of the pegs for now, and just leave the hard core and the matting made from more steel, and let us look around it now to see what we're really trying to get to. If we go to a different angle and zoom in, you notice that there's a space underneath. There's a space between the actual floor and the steel. This space is necessary so that if the steel is allowed to go to the very bottom of the mix, then what will happen, if you take up the slab afterwards and look underneath it, you'll be able to see those steels protruding or showing. When that happens, it allows the steel to absorb moisture, it will rust, it will swell, and once it swells, it will crack the entire concrete slab and your whole work would have been wasted. So to avoid that, you keep the steel or you keep the matting isolated in the center of the slab so that no point of it is exposed to the air. How do we keep it up? You use some spacers here. Would be some, you could probably use stones. In this case, we are using some little concrete pegs that keep it high enough off the ground so that when the cement is poured, as we said before, the cement would pour all around it and underneath it so it is completely covered. Alright, hopefully that is now understood. Let's go back to where we were. So with our ground excavated, with the hard core placed, with the matting placed over that, and then your spacers underneath to keep the matting off the ground, you can now put back, or well, you would have, or pegs and plyboard have been in place of course from before, and the last thing to do would be just to pour in the cement and the project would have been done. Leave that to dry and that's it. Once it's dry, and it will take about 2 weeks for this to properly cure, and drying and curing is two different things. When it is dry, you can literally touch it on the outside and it will feel, you will feel no moisture on your fingers. It will be hard on the outside, but if you were to break it up and check on the inside, you might find some areas where the concrete or the cement is still wet, and so it will take roughly 2 weeks for all of that moisture to properly leave the concrete. Now you can't allow it to dry too fast. If it dries too fast, it will crack, and if it dries too, and if you try to rush it or start to use it before it is too dry, then it will be too soft to be used. So as soon as you try to walk on top of this after a few days, even though it feels tough, it's still sinking to an amount that you probably won't notice until probably a few weeks or months afterwards. You notice that your slab is now twisted and cracking because you did not wait the appropriate time before applying pressure to it. Alright, let us remove some of these layers now to get rid of the ground. Let's get rid of the pegs. So, well, let me do this in proper sequence. Once the slab is dried, the next step now would have been to remove the pegs. With the pegs out of the way, it leaves no space for you to get rid of the plyboard. You can just remove the screws, a sledge or a chisel, and break those off gently and get rid of the plyboard. Now the plyboard is out of the way. There is a bit of space left back where the plyboard and the pegs were. Now remember that soil that you had removed from the ground in the first place while excavating. There's a process that you already know called backfilling, which is where you take that soil and you put it back to where it came from, or you use some of it and refill that space. And so that is it. Now your concrete slab would have been perfectly done, perfectly square if you'd done all the proper procedures, and that's a successful project. How does this apply to you now in your SBA endeavors? With the plan sheet, as we said, step 1 or page 1 is for the isometric drawing. So if you find that, make a drawing of it and bring it to your plan sheet and paste it there. And there we go. And your drawing should be a label drawing, of course. You can do it however you can, whether by hand or if you have the computer software and computer knowledge or the knowledge to use the software, then fine. It is your choice, as long as it is properly done and looks neat enough to be submitted on your plan sheet. If you're not too much of an artist or a TD student and you can seek help somewhere to get the drawing section of it done, then do so. This is an example of a picture that I took from the software that we just used. You can do it that way, or you can save it. See if I can find the other one, or you can save it like this one here that I'm going to put in place, which is simply lines. This is what your drawing would look like if you were to do it by hand. Alright, and this is good enough for a full mark if it is done neatly. Page 2 requires you to do the orthographic drawing, and I already saved my orthographic on my desktop, so I'm just going to find it here. Go back to the drawing, or go back to the plan sheet and paste the orthographic drawing there. And so that's page 1 and page 2 done easily. But let us explain a little bit about the orthographic font for a bit. If you had watched the first video, then you'd have been familiar with what orthographic view is. But say you did not, let us just go into it for a bit. An orthographic view, an orthographic drawing, is simply asking you to show the object or the project from multiple views, from all angles possible. So putting all pieces back into place, and let us look at it from an isometric view. There we go. So this is what you draw from your isometric, and that's 3D, but your orthographic asks you for 3 different sizes. What you're seeing here is where I'm showing with the mouse is the top. Here is the top view, so if you're above looking down, this is what you would see. If you're standing to the left side, then you'd see only this section. If you're standing to the right side, you'd see only this section. So there are 3 planes: top, left, and right. In this case, the right would be the front, similar to the box here being shown on the software. Top, left, and front. Alright. Now, orthographic view asks you to show all these 3 views. So I'll go around the object now to show you what those 3 views look like. So that's above looking down at it, just the box with the pegs around it and the slab in the middle. This is from beside, which is pretty simple. And this is it from in front. And so these 3 drawings will be now placed into the drawing, so you can see all 3 of them at the same time. And here we have our orthographic drawing already done. Let's get rid of that and get rid of that. So this is what our orthographic drawing is. And let's just switch to a different view that is easier to see. What do we have here? We have firstly our front top view, which we draw first. Then from the outside edge, draw a vertical line called projection lines. Again, another projection line from the other side, and it goes upwards, and from there you draw your front view. Once front view is done, let us draw now some horizontal projection lines. Horizontal meaning sideways. So let's draw one horizontal projection line from the top of the front view and from the bottom of the front view. From the top of the plan view and the bottom of the plan view. And these 4 lines would go across. From that point, you now draw 45-degree lines starting at the very bottom right corner of the front view, and these 45-degree lines would meet up with the 2 bottom horizontal lines right here and here. Say again, here and here. Once you have these 2 lines, you turn the direction of the line. So let us say that the line is a path. It travels on this path, and once it reaches the 45-degree line, it changes direction and goes upwards instead. So you'll also now draw these 2 lines in place, and these 2 lines would create now a box here that you'd use to place the final view, and all of that will be done. And once you save that as a picture, or if you're doing it by hand, once you do that drawing, take a picture of it, save it, send it to your computer, or send it to your email, download it, whichever way. Once you get it to be a soft copy, you can now go to your plan sheet and paste it there. That is done. Page 3. Page 3 now asks you for steps and procedures. Let's just delete these samples that were there to give you a start. For page 3, it's asking you for the steps and procedures in making the concrete slab. First thing that we did was layout. What did we lay out? We lay out the profile. And so the profile board would have been laid out. Alright? Afterwards, you would have been excavated. Or excavation, either way. After excavation, it is now time to lay hardcore. If you lay your hardcore, it is time now to set up formwork or assemble. Formwork has been assembled, and that includes driving the pegs into the ground and nailing on or screwing on the plyboards onto the pegs. Once that is done, it's now time to construct your reinforcing, and that's reinforcement. After constructing the reinforcement, you would now tie them together with the binding wire. Once that is done, all you have to do now is pour your concrete. Well, let's say pour mortar. Once that is dry, it will now become your concrete. Let's break down these steps now. In laying out the profile boards, you need what they normally call English cord. You may need pegs. You may need batter boards to drive the pegs in the ground. You may need a hammer, and you may need a level, a square, and a number of other tools that you will have to fill in. Just think about the process carefully. You've done the practical already. Think about the process carefully, and once you remember all the tools, fill those into this section. Tools and materials, that is. Next step is excavation. What do you need for digging? May need a shovel, Depending on the size of the excavation, you may be using machines like a tractor or backhoe, but in this case you may not need those things. There's a shovel, maybe an axe, maybe a digger, and you just list those things that you're going to need now for the process of excavating that small spot of ground. Laying hardcore. For laying the hardcore, you just need a shovel and probably a wheelbarrow to bring it to the site. Once you brought it to the site, you can now distribute it or spread it with a shovel and compact it by beating it into place, or if you have a compactor or a vibrator, you can use it to set it into place. Assembling formwork is you may need the hammer for driving the pegs into the ground. You may need a drill for screwing the formwork together. You're going to need plyboard itself. You may need to cut the plyboards, so you may need a circular saw. Cut those boards to the shape that you want, and etc. You fill those in. For constructing reinforcement, you may need a steel cutter or a grinder, a chop saw, and you may need binding wire. You might also need a tape measure to make sure the distances between each grid is equal and consistent. And those are some of most of the things that you may need for that step. In pouring the mortar, you may simply need somewhere to mix. Well, that's a step that we did not put. Apart from before pouring, you might need to do some mixing. In mixing, obviously, shovel, need water, cement, gravel, sand, alright, and something to transport it. In terms of the pouring section, you may need wheelbarrow, because you can transport it in the barrow, or you may need buckets, or in case if it's a large scale production, you may need a mixer, but this is not, and so using those now you'd pour. After pouring your cement, it's time to now rod or screed. Basically that's the stage where they would now use a piece of 2x4 board to level off that cement so that it's nice and flat. Let's see if we can show you in the video here. Here we go. So in doing this now, you're simply getting the cement to be leveled and properly distributed, making sure you get rid of any lumps, right? And if you get rid of all the lumps, you might also want to tap the side of the frame with a hammer or something heavy enough to shake the whole pour somewhat, and in shaking it you'll be able to get rid of some of the bubbles. Now you cannot over vibrate it, because what that will do is sometimes make the concrete weaker, but just a few taps will release extra bubbles from below it, getting rid of any faults that can come back to create problems later on. Alright, and for that you may need store pole. That's it. On this section now, it is time for you to list your tools and materials. Well, not tools, just your materials. In this case, you may need cement, need gravel, you need sand. You're gonna need rigid steel, and what else? Cement, gravel, sand, rigid steel, binding wire, and whatever else that may classify as materials would also go inside of this. Alright, and how do you differentiate between materials and tools? Tools are what you use to get the job done. Materials would include anything that will become a part of the project. So if it is used up in while making the project, then it's considered material. Your tools now would go back with you as your bag. So for example, your hammer would be a good tool, and the nails that would go into a piece of furniture would be material, because you're not taking those nails with you when you're done with the project. Those nails will become a permanent part of the project, so that's why it's now material. Alright, in this case you may need to say, alright, 5 yards, depending on what you're doing. I know you may not know the measurements, but what you need to do is come up with an estimation, say 5 yards of sand and about an equivalent amount of gravel. It's going to ask you what material it is, and this is crushed stone. That's what gravel really is. Sand is going to remain as sand. There's rigid steel, which is what type of steel is it? I believe it is mild steel. Let me spell that properly. Mild steel. Binding wire is also mild steel. Cement, the material for cement would also be cement. Alright, and we say we might need 5 bags, 5 yards. Let's get rid of 5 there, and that 5 there, and so 5 yards there. So 5 yards of sand, and you normally measure in yards, but this one you'll leave the same. Unit price, for example, $1,000 per yard, and you need 5 yards, that would be $5,000 as an example. These numbers that you put in terms of the unit price don't matter that much. It is just to demonstrate that you know how to now take the number, quantity, and estimated price to convert that to now the extended price, which is this form, this section here, this column here on the table called cost. Alright, so for example, 5 bags of cement, size, how much is it? No, I'm not sure how much cubic inches or weight is normally in a cement bag. So let's leave that part blank for now. And then the material, of course, would be cement. The measure, they come in bags, and the unit cost 1333. Let's use the same number from the last example, 1,333 per bag. And so if we have 1,333 times 5, that's $6,665. That's for one item. Do the same thing for the gravel, same thing for the sand. Steel, you may need, say, 8 lengths, and they're normally 6mm by 30 feet. Mild steel, and they measure It's normally just one length is the term. Unit price, say $2,500 each, and you need 8 of them. So that's 2.5, and that's not the actual price. $20,000. You put that in, and when you're done, you put your total at the bottom, and that's a completed plan sheet. So therefore, you would have isometric on page 1, orthographic on page 2, your list of steps and procedures, along with materials and tools on page 3, and on page 4, a quick breakdown of those materials, what they're measured in, and the extended cost of each thing. This is 35 marks. You did not need to do the practical, but if you properly fill out the plan sheet and do some accurate drawings, then you'll be on your way to grabbing most, if not all, of those marks once it's properly done. As soon as we get further word from CSEC officials as to what is the plan forward. But nevertheless, your grades are outstanding. Please do these as quickly as possible. Further questions, you can always check. And these pictures will be sent in the group and also uploaded to the Google Drive. So what you can do is use these drawings that I'm going to provide to you as a guide to do your own drawing. Also, to note, on the drawing, you may need to do some labeling for one of these. Let's turn on annotation layer for a minute and see here now. Here we have labeled in the cross-section view on isometric all the things that we need, which is right here. We have our plyboard, 5/8 plyboard for formwork. You have our reinforced concrete slab, which is what you're trying to make. There are pegs, which are 50 by 50 millimeter, in other words 2 inch by 2 inch. There's earth, the soil itself or the ground itself that you're excavating to get the slab into. There is also on this section spacers, and this one here would have been now your matting, steel matting, and that's made from 6 millimeter rigid steel. Good. And in the center here, pointing all the way down to the base of the whole setup, is that section, which is now the hard core that was laid, the gravel that was spread over the whole excavated area. And that's the full project.